Hi everyone, today we'll be learning about independent events. So to start with this do now, we want to determine if one event has an effect on the chance that the other event will occur. So if you want to take a second and pause the video and just fill in the first column where it says, does one event affect the chance that the other event will occur? And I'll put the answers up. Okay, so hopefully you got the same answers here. And now I want to fill in the title on the next column where that little star is and write independent. And take a second to think about, do you think of the events in the first column are independent of one another? So this first one, having a thunderstorm and having a football game, yes, one event is definitely going to affect the chance that the other event will occur, so these are not independent of each other. But the next one, where one event has no effect on the other event occurring, these will be independent of each other. So it's kind of like everywhere we have a yes, we're going to put a no in the next column, and where we have a no, it's going to give us a yes in the next column. So if we take a second and think about this pattern here, we can answer the next question. What does it mean for two events to be independent? That means that the two events have no effect on each other, right? Everywhere we have a yes in this first column, we have a no in this column, which means one event does not affect the chance that the other event will occur. Then we can fill in here, if two events are not independent, we say that they are dependent events. So this table just gives us some examples of independent and dependent events in the real world. And now we can jump into different mathematical tests we could use to test for independence. So again, two events A and B are independent if the occurrence of one event has no effect on the probability that the other event will occur. The first test we're going to use to test for independence is the probability of A given B equals the probability of A. If this is true, then two events are independent. So I'm going to use this test to do the next example. So we have data from 200 flights collected. The flights were categorized as domestic or international and late or not late. We want to figure out are domestic flights and late flights independent events. So first we want to start with our two events, which they already tell us on the top. We're going to use domestic flights and late flights. So I'm going to fill in the solution area here just to break down the steps. I'm going to have capital D stand for domestic and L for late flights. And then our next step would be find the probability of, well, the first event I wrote down is domestic flights. Whatever this single probability is here, so if I'm comparing the probability of D, D has to be the first thing in my given statement. So I need D given L. Okay, so I'm always going to take this first one and put it in my first slot in that given probability. So in my solution area, I can find the probability of a domestic flight. Look across at my total is going to be 150 out of the total 200. And then I want to find the probability of D given L. So remember that whatever's given is always in the denominator. So my late flights are going to be in the denominator. That total is 40. And on top, I want the domestic and late flights, which is 30. And now my last step, I want to see if these are equal to one another. So I want to see, does the probability of D equal the probability of D given L? And we could simplify those fractions we got in the second step in our calculator and get 150 over 200 equals 0.75, and 30 over 40 simplifies to 3/4, which is 0.75. So these are independent events. Then if we flip to the next page, I'm going to go through the second test we can use to determine if two events are independent. So events A and B are independent if the probability of A and B equals the probability of A times the probability of B. And I'm going to do this next example using that test we just filled in. So I have the same data, and now I want to figure out our international and not late flights independent events. So I'm going to have I equals international and I'll use N for not late. Okay, so if I'm using that second step, I want to find the probability of each event. So the probability of an international flight, I can look at my table, is going to be 50 out of 200. And probability of having a not late flight is going to be 160 out of 200. My next step, I want to find the probability of international, let me fill in this left side, international and not late. So probability of international and not late. Let me look back in my table here. So international and not late is going to be 40 out of my total 200. And then I'm going to find the probability of international times the probability of not late. So we already did that in step 2 and found these separately. So I want to do 500 over 200 times 160 over 200, which if you throw that in your calculator and simplify will equal 1/5. And then step 4, I want to see if these are equal to each other. So does the probability of I and N equal the probability of I times the probability of N? If we simplify our first step, our first number we have here in step 3, 40 over 200, that equals 1/5. And we found that probability of I times probability N equals 1/5. So these are independent. Okay, so I'm going to move down to these two exercises. Both of these are Regents questions, so I'm going to help you guys set these up. And then you can go ahead and finish them and submit these 2 pages. Sorry, and submit all of these pages at the end of the video. So this first one gives me the results of a survey of a student body about television viewing preferences. I want to see, are the events, is a student male, and student prefers reality series independent of each other. So we just went through 2 different tests that you can use to test for independence. It is totally up to you, whichever one you prefer. Sometimes depending on the question, it'll be easier to use one than another. But if I set up using my first test, I want to see does the probability, so we have male and reality TV. So male given reality TV equal, since I wrote male first here, I'm going to check does that equal the probability that the student is male. That's one way we can check, and you can get that information from the table. Or like we just did in that second test, I can see does the probability of male and reality TV equal the probability of being male times the probability of preferring reality TV. So it's up to you guys, whichever test you're comfortable with. Both of them work, both of them are acceptable. You could try it both ways to just double check yourself. So you guys can go ahead and finish exercise 1, and I'm just going to set up exercise 2 for everyone, and then you're on your own. So exercise 2 tells me a student is chosen at random from the student body at a given high school. So the probability that the student selects math as their favorite subject is 1/4. The probability that the student is a junior is 116 out of 459. The probability is a junior or chooses math as their favorite subject is 47 out of 108. So I want to figure out the exact probability that the student selected is a junior whose favorite subject is math. So that's just a way of writing. I want the probability of a junior and a math lover. Okay, so that's really an intersection. To figure that out, remember I'm going to add up the probability that I'm a junior plus the probability that I like math. But then the problem here is I need to subtract the intersection where both people are already included. So these juniors and these math people, I don't want to double include them, so I'm going to subtract the probability that they're a junior or they chose math as their favorite subject. So that's how I'm going to set that up. Then it says, are the events the student is a junior and the student's favorite subject is math independent of each other? So again, we have two formulas we can use here. I can see, is the probability of them being a junior given that they like math equal to the probability of them being a junior? Or I can see probability of junior and math equal to the probability of being a junior times the probability of math being your favorite subject. I think in this case, it would definitely be easier to use this second test since in the example or the part right above it, you're going to have the intersection and the question already gives you the math probability and the junior probability. So even though it's up to you in this first exercise which test you want to use, it definitely makes sense to use that second test in exercise number 2. So please just finish these two problems, get a final answer here for both of them, and show your work, whichever test you feel comfortable with. Let us know if you have any questions, and just submit all of these pages on Canvas.